and this voltage level will reach at 1 volt equal to pin number 15. When these two pins will equal, this IC will shut down. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. For TL494 calculation and programming and how this circuit is working, this is our error amplifier calculation session. How this IC monitors the voltage, how we apply our reference voltage at one pin of error amplifier, that is pin number 2, and how this IC will sense the feedback. We are calculating this circuit for 15 volts. So when we have 15 volt at the output, this IC will take 2.5 volt. So this IC will maintain its duty cycle. If the voltage will increase, this IC will reduce its duty cycle. When the voltage will increase, voltage reached at 16.7 volt. When the voltage are decreasing, the IC will adjust its duty cycle, and when the voltage will less than the reference voltage, which are here 2.5 and 2.2, this IC will try to switch at full rate. But when the voltage will increase at reference pin 2.6 volt, 2.7 volt, this IC will reduce its duty cycle to reduce the output voltage. How the error amplifier for current monitoring section is working: we apply a 1 volt reference at pin number 15, and here we have, I am simulating this feedback. Actually it is a load sensor, current sense resistor, which will monitor the load current. It will provide voltage at this pin. When the voltage will increase than the rated value, that is the error amplifier input pin, when the feedback will, current sense feedback will increase or will equal, this IC will cut off its switching to protect from overcurrent. We will calculate and we will arrange this practical circuit to monitor this function. Let's start. I hope so you will subscribe my channel, and if this video is good for you, you can hit the like button. Let's continue. In our last video we discussed how we can configure TL494 and how we can make a wiring for TL494 to take our required frequency. We calculated this push-pull driver for 60 kilohertz frequency at pin number 5 and 30 kilohertz at each pins in the output section. And we calculated dead time, how we can adjust dead time and soft start, dead time between both channels, and how we can calculate, how we can adjust the feedback. But today we will discuss the most critical point of this TL494 for regulation. We will discuss the error amplifiers. What is error amplifier? This IC have two error amplifiers. It is called error amplifier number 1 and error amplifier number 2. Pin number 1, 2 and 15, 16. Error amplifier, basically it is a operational amplifier. We apply some reference voltage at one pin and we give some error voltage or our required voltage which are to be monitored to the second pin. So this IC will check the difference between both pins and it will amplify the error, how much there is a difference. Error amplifier number 1, that is for voltage mod. Error amplifier number 2, that is for current mod. It is to regulate the voltage and it is to limit the current. It is also called short circuit protection circuit or current limiting circuit. So it will provide a sink current of 300 microampere minimum, 300 to 700 microampere, which is to be set on feedback resistor. First of all, from our last setup, we will remove pin number 15 from the 5 volt reference, and we will remove pin number 16 and 1 and pin number 2, and today we will program them independently, because in TL494 there is just only single ended power supply, that is V reference. When we apply voltage at pin number 12, it gives us 5 volt output as a V reference from reference regulator, and it provides biasing voltage to the amplifiers and internal circuitry. So we can say we have just only 5 volt reference power supply for biasing these circuits, that is from reference regulator. We can design this IC to take positive output or to take negative output, which type of converter we are designing. So we can configure the both circuits for positive voltage or for negative voltage. For positive voltage, we apply a reference voltage at pin number 2, that is inverting input, and at non-inverting input we take a voltage divider network and we make a ratio between these two resistors. Also for negative output, V reference and output voltage, and it is applied here. Pin number 1 non-inverting input will be grounded. For example, we need a power supply for 15 volt 10 ampere. As we discussed, we need a sink current 300 microampere to 700 microampere. Just for demonstration, I will select 500 microampere. We have reference voltage 5 volt. We need 2.5 volt reference for voltage mod amplifier, pin number 1 and 2. For current mod we need 1 volt. I will discuss why we need 1 volt. So here we can select 2.5 volt reference, and from 5 volt reference voltage, which is from pin number 14, and we need current, that is 500 microampere or 0.5 milliampere, so it is 10k resistor. If we need 2.5 volt reference, we can just only divide two resistors, 5 kilo ohm, 5 kilo ohm. When we will divide two resistors, 5 kilo ohm, 5 kilo ohm, we will 2.5 volt at this pin. Now if I need 15 volt here in the output section, and this node, this pin is connected at output terminal to sense the voltage, from 15 volt divided by 0.0005, so we need 30 kilo ohm resistor, 15 volt. So total resistance, this resistor and this resistor, we need 30 kilo ohm. And at this node, when the 15 volt are available here, at this node we need 2.5 volt. So we can calculate this resistor value. 2.5 divided by 0.0005, it is 5 kilo ohm resistor. From 30k minus 5k, it is 25 kilo ohm. Or we can calculate 12.5 volt divided by 0.0005, 25 kilo ohm. So when we will find 15 volt in the output, at that time, at this point we will take 2.5 volt. So this IC will determine that the voltage are received. Now we have to set again, we should consider the regulation. Normally, for best practice, the gain for the amplifier, it is set around 100 or 101. Now when we have 2.5 volt here and we need minimum 2 milliampere source current for feedback, we will set 5 milliampere. So we will calculate this resistor. To calculate this resistor, 2.5 divided by 0.005, 5 milliampere, it is 500 ohms. And if we need again approximately 100 to take a good regulation from this regulator, 500 multiplied by 100, so it will around 50k resistor. So this ratio should be 100 or 101. If we set 101, so it will 50.5k. If we will increase the more gain, so it may lead to the ringing factor. Or if we select a low value resistor, that will cause to slow response in the feedback system. So these resistor values will maintain 15 volt in the output. Now we can calculate the output voltage using this formula. Vout will be V reference. V reference we divided 2.5 volt. Here 5k, so 2.5 volt, 2.5 multiplied by 1 plus R1. R1 is 25 kilo ohm. 25 kilo ohm and 5 kilo ohm. 25k divided by 5k. So the output voltage will 25 volt. So this will the output voltage, because we connected the feedback at non-inverting input. If there is the offset issue, to minimize the offset, we can use a potentiometer here to adjust the output voltage. So it is for voltage mod error amplifier number 1. And we can also design error amplifier for current limiting. To set the error amplifier, we need a special care. That is for pin number 15 and 16. To set current limit as a short circuit detection, we have to configure pin number 15 at around 1 volt. If we set this pin at 2.5 volts, in that case we need a very high value resistor at current sense, because here we have to monitor the short circuit current. Similarly, we can use a resistor value 4 kilo ohm and 1 kilo ohm, or we can set 8 kilo ohm and 2 kilo ohm resistor to give a 1 volt reference here at pin number 15. Now if we apply 1 volt reference, as I discussed, we need 15 volts, 10 ampere. For voltage mod, we calculated these two resistors, 25 and 5 kilo ohm. For current mod, we need a resistor in the ground path, so all the load current will flow from this resistor. Load current 10 ampere and a load swing 1.5 ampere. So the total short circuit current should be I out plus IL divided by 2. We will take the average of this swing. So 10 ampere plus 1.5 divided by 2, it will 10.75 ampere. So this is the short circuit current. At this current we need 1 volt from this resistor, because according to Ohm law, how much current will flow, it will cause to drop the voltage across this resistor, and these voltage are applied to the non-inverting input of this error amplifier number 2. So to determine the resistor value, V over ISC, 1 volt 10.75 ampere, 1 divided by 10.75, so it is 0.093 ohm. 0.093 ohms. So we can select the next closest value, that is 0.1 ohm. When there will a current flow above than 10 ampere, it will provide 1 volt, so it will equal to this 1 volt, and at the same time this error amplifier will stop the switching of the IC. When the current will increase at a specific point, at that time it will provide a short circuit protection to the circuit. So in our last video we connected pin number 16 and pin number 1 to the ground. Pin number 16 and 1 to the ground, but today we will remove it. We will remove pin number 1, pin number 16 from the ground, and pin number 15, pin number 2, and we will connect a fixed gain at pin number 3 of 100, which we calculated, because this gain is just only applying voltage at pin number 3. We are controlling the gain at pin number 3, and here we are controlling the dead time. Dead time from minimum to maximum, between starting and ending edge. But here we are controlling the duty cycle by controlling the voltage at pin number 3. But today we will remove this pin number 3 and we will give a fixed gain. So I will remove pin number 1, because before this we applied a fixed difference between the both pins of error amplifier at the inverting and non-inverting input, and we have to remove pin number 15. So now error amplifiers are free from all type of inputs. Now we will apply voltage at pin number 2, and we will give a fixed gain of 50 kilo ohm resistor at pin number 2 and 3. Here is pin number 3. So this resistor, it is variable resistor, but I set it at 50 kilo ohm. So this resistor 50 kilo ohm, and now we have to set this resistor at 500. So this variable resistor I set it to is 510, so multiplied by 100, it should be 51k. So we will set it to 51k to give a 100 gain. So this pin will connect it to the pin number 3 of this IC, because this end it will be connected to pin number 3. So this resistor is connected to pin number 3. Now we have to connect the center pin of these two resistors to pin number 2. Now we have a fixed resistor of 50k between pin number 2 and 3. We have a resistor here at pin number 2 and the voltage reference. Now we have a potentiometer with 5 kilo ohm and 5 kilo ohm between ground and the positive voltage. So it is 5 kilo ohm and 5 kilo ohm. So this potentiometer 10k I am using as a 2 resistors. It is 10k potentiometer, but I divided it between two values, 5 kilo ohm and 5 kilo ohm. So this end, one end, the lower end will connect it to ground, the upper end to V reference. V reference is positive 5 volt from pin number 14. So this pin will go to ground. Now we have 2.5 volts here. Let's check it. We are providing 5 volt and we are taking 2.5 volt reference. It is 5 volt and we are taking 2.6 volt divided, and it is applied to pin number 2. Now we have to provide a sense line with 25 kilo ohm and 5 kilo ohm. So when we have 15 volt here. These voltage will 2.5 volt at this pin. We applied a reference. When this reference will equal to this, at that time, this IC will manage its duty cycle at that ratio. This potentiometer is 25 kilo ohm. We will use as a top value, and here we have 5 kilo ohm. We can use resistors when we want to design a practical circuit. In that case, we have to use resistors, but the tolerance must be the lowest range, so it is 5 kilo ohm. So we will use these two potentiometers in series, and we will take the center point as a voltage divider. This potentiometer is 5 kilo ohm. It is 25 kilo ohm, 5 and 25, 30 kilo ohm. So these 30 kilo ohm potentiometers are here, and this center point will connect it to pin number 1, so that when there is 15 volt at this end, it will provide 2.5 volt to the pin number 1, and we are generating 2.5 volt through this reference, through these two resistors at pin number 2 and this voltage divider network at pin number 1. Basically, it is the output pin of the any power supply. This time I am simulating this voltage. This will go to pin number 1 of this IC. This time we programmed the pin number 1 and 2. Here we have pin number 2, which we applied a reference voltage, and we have feedback voltage 2.6 volt. We applied a reference voltage 2.5 volts by programming this resistor. These two resistors here, 5 kilo ohm, 5 kilo ohm, so it will divide 5 volt reference from pin number 14 and ground, and 500 ohm current limit resistor to pin number 2, and a gain control resistor at feedback resistor at pin number 2 and 3. So we applied voltage reference at pin number 2.5 volt reference at pin number 2, and when we have 15 volt output in the output section, at that time our this voltage divider network 25k and 5k resistor, it will provide 2.5 volt reference at pin number 1. We applied a reference to pin number 2, and we received a feedback voltage when we have 15 volt here in the output. At that time our this voltage divider network will provide 2.5 volt to pin number 1, so that this IC will know that the output voltage are maintained. Now we have to connect this current limit circuit. For that we have to connect pin number 15 to a voltage divider network with 1 kilo ohm and 4 kilo ohm. I have this 1 kilo ohm resistor and 4 kilo ohm resistor by adjusting this potentiometer. So we will connect one end to the reference voltage and this end to the ground, and we will take 1 volt reference for current limit error amplifier to sense the current, to limit the current for short circuit detection. Now I connected 1 kilo ohm resistor to ground and 4 kilo ohm to V reference, and we will take the center node of these two resistors and we will connect to pin number 15 to apply 1 volt reference for current for short circuit detection circuit as a reference, and we will apply a feedback circuit for providing 1 volt at full current. This is the output current of any power supply. This RL value, it should be the minimum value, so that the dropped voltage at full current must be 1 volt. Now what we did, we finalized our setup. we applied 2.5 volts at pin number 2, and this is the feedback at pin number 1. This time I am simulating this signal. When we have 15 volt output, at that time this network will find 2.46 volt, we can say 2.5 volt, and this IC will adjust its duty cycle at this point. We provided 1 volt reference, 987 millivolts reference at pin number 15, and this time pin number 16 is 0. So that means there is no current flow. When there is a current flow and pin number 16 will receive voltage, and this voltage level will reach at 1 volt equal to pin number 15. When these two pins will equal, this IC will shut down. It is for short circuit protection. Now when the voltage at pin number 15, 987 millivolts, and it is 977 millivolts, when it will reach at 987 millivolts, what will happen? This IC will know that there is a overcurrent. So according to our calculation, if we connect 0.1 ohm resistor for 15 volts and we program pin number 15 to take 1 volt, 984 millivolt, this is due to the tolerance of the resistors. So this resistor is for voltage feedback. It is programmed at 2.5 volts, and when there is a 15 volts in the output, 15.36 volt, this IC will find 2.4 volts, and if there is a short circuit, so this IC will cut off the command. Why? Because the feedback at pin number 16, that is now 1 volt. So this IC will go in protection mode. If the current is less than 10 ampere and we are finding voltage 817 millivolt that are less than voltage at pin number 15, at that time this IC should generate pulse width. It will work, and here we have 2.45 volt, that means there is output. If the output will increase, then the rated voltage, for example we have to find 15 volt, in that case the IC will reduce its duty cycle. Why? Because this time the voltage at output are 16 volts. When the voltage are 16 volt, at that time pin number 1 have 2.69 volt. So if the voltage increased, at that time this IC will also go in disable state. If the voltage will reach within the required window, this IC will start switching again. This time the voltage are 15 volt. This IC is switching correctly, and we are finding the voltage at pin number 1 2.5 volt, 2.4 volt, pin number 2 that is 2.5 volt. When the voltage will increase at pin number 1, this IC will reduce its duty cycle to drop the voltage in the output side. And if the current will increase, in that case we will find voltage at pin number 16, and this IC will become to know that there is overcurrent. To protect from overcurrent, this potentiometer, this time I am using potentiometer. Actually we have to use a shunt resistance to provide output current, to detect the output current, and when the current will flow from this resistor, it will provide 1 volt at full current, which we calculated. So this circuit will work like this. So friends, I hope so this video is informative. If it is informative, hit the like button. If you have any question, kindly let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.